All right, now let's try this one. So same thing. Let's start. So what would you read this ECG for me, please?
Okay. The rate.
Mm-hmm.
Say like 4 boxes.
Okay.
So
You
that
don't
would.
really need to tell me the number. Tell me if that's a normal rate or not.
Oh, okay.
Is
Um,
it normal rate or not? How many big boxes falls within normal rate for analysis Fiji?
3 to 5.
3 to 5. So being asked 4, is this normal rate or not?
Normal.
Normal, right? So I don't really need to say the number, but I can just say, okay, this is normal just because it's within 3 to 5. Good. Okay, what do you check next?
Rhythm
Reading. Tell me about the reading.
is constant.
Rhythm is what's the proper term?
Sinus.
No, what's the proper term? Rhythm is regular, right? Equidistant is regular frequency. Good. And then what else am I checking for in rhythm? What else am I looking for?
Then uh,
Is it sinus or not? So is this sinus rhythm or not?
yeah, sinus.
How do you know it's sinus?
Okay.
Hmm?
Huh?
How do you know it's sinus?
Yeah, that's what I'm checking. I want to check first. Make sure. Yeah, it's sinus.
How do you know?
You have to make sure the P and then the Q, R, S, T, they
So
follow.
where's my P wave here?
Your P wave is here.
For some reason, I can't see your cursor. I usually
Um,
see in other people.
oh, sorry. Let me.
So which wave is the P wave? On the ECG.
Like as soon as after that the inverted T, you see the
All
P
right,
wave.
good. So P, QRS,
Yeah.
P, QRS, good. And each of them have all the carriers have P wave and all the carriers are followed by T. Good. Right. So the reading is what? Regular and
Sinus.
sinus. Okay, what do you check next?
Um, we check make sure like the P wave is above the T wave. I mean, make sure
So
the
what do
T.
you check there? Be systematic. So you don't miss anything. What would be the best way? Good. So you start with your P, correct? Very
Mhm.
good. Now, tell me the P. Is the P abnormal in shape, size, height, whatever?
P is normal.
P is normal in shape, it is a good. So what do you check next?
Um, you check your QRS to
Mm-mm,
see
mm-mm. I check the P before I go to carriers compare. What do I check next?
um the PR interview.
PR interval, right? Okay, so tell me about that.
Um, PR interval is is longer.
It's longer. How long is it?
3 boxes.
3 boxes? Are you sure? This is the beginning of P wave to the beginning of Keras complex. How many boxes is that?
Oh, 2 boxes.
2 big boxes. And how long is that in seconds?
0.4 seconds.
0.4 seconds. So tell me, is that normal?
No.
Is prolonged. Make sense?
Yeah.
Right. So tell me what that means. I see my PR interval is prolonged. What should I be thinking? What should be on my mind?
Thinking like there's something wrong at the SA node.
SA node. Are you sure? What does the PR interval represent, Doc?
The PR
What does the PR interval represent?
atrial depolarization.
P wave represent what? P wave represent what?
SA.
No, P wave represent what?
Atrial depolarization.
Can you see SA node depolarization on the ECG? No, you can't. Well, how do I know that SA node is firing? Because I see P wave. Once the SA node fires, P wave comes up, meaning atrial depolarize immediately. All right, so PH, okay. Now, what is my PR segment? I have P wave, atrial must depolarize. Why is there this pause here?
That's for the to give a chance for the ventricles at the AV node to give a chance to.
So what does the AV node do? Why is that pause? What does the AV node do to cause that pause?
There's it gives the time for the ventricles.
I know what you're saying, but what does it do exactly to do that, to give the ventricle time to feel? What does the AV node do? Why do I have that pause? What's going on with the AV node? It slows down.
Yeah.
If you look at the speed of conduction, right, AV node is the slowest, has the slowest speed of conduction of all the conduction cells in the heart. It slows down. It's going to slow down the action potential so much that the ventricle has time to feel before the action potential goes through to the ventricle. Does that make sense? Hence, the straight line here, the pause. So now this patient has prolonged PR interval. What would be on my mind in this person? It's longer than it should. What should I be thinking?
There's a problem at the AV node.
Thank you very much. That's what it means. The AV node is slower than even usual. We know it's very slow. It's the slowest. But now it's even slower in this person. That's why the PR segment is longer than it should, and my overall PR interval is prolonged as well. And what we call is like AV node block, most likely, going on here. Does this make sense? Yeah. So far, so good?
Yes.
So what do we just enter now, stylishly? We just enter the realm of what? Art blocks, which are one of the causes of bradyarrhythmias, right? Or abnormal heart rhythm. Excellent. Yeah. So is there anything else wrong with this ECG? The KRS complex, the QT interval, is there anything else wrong?
The inverted T wave.
Right, so the T wave is inverted. Okay, I'm not sure which East lead we're looking at here, but it might be just be due to delay. If it's like AVR or V1, because of their position, sometimes T wave can be inverted because they are like opposite to the ventricle. So yeah, so let's assume that's normal here because maybe this is like AVR or V1. And then we have, but the only abnormality here, let's say, is the prolonged PR interval. So my diagnosis would be what? This would be what? What kind of heart block is this? This is your first degree, right? First degree heart block. So what will I see in first degree heart block? Only what? Prolonged PR interval. Basically, there's a block in the AV node, but it's not that bad. It makes the AV node slower, but it's not completely blocking, right? Conduction yet. Hence first degree, like a mild AV block. Make sense? So far, so good?
Yes, sir.
Okay. So let's move. So I have two ECG. We're going to start with the one at the top, and then we'll go to the one at the bottom. So let's get the one at the top. Same thing. Read this ECG for me.
Um, it's definitely so rate
Mm-hmm.
on. But so like here is kind of like because the space between the R, like the RR intervals to measure is all different.
So what would be the best strategy here? There's still a way you can estimate the rate. What should I do?
Maybe use the longest one.
You look at the longest and the shortest and find their average. Do you understand that?
Mm-hmm.
Yeah. So what will be the average at rate in this percent?
This is one. Like 31.
About 31.
Mm-hmm.
So what is that? What is the interpretation of that?
Oh, that's bradycardia.
And that is approximately 31 depends bradycardic. All right. So what do I do next?
Rhythm.
What will be my rhythm?
Uh, irregular
Regular. Why?
because the space between the R intervals are not constant.
Okay. What else do I do next?
Um, let's see.
Hmm?
We check the PQR. I think there's absent T wave, so it's not
This is your T wave there at the
oh
bottom there, right? So what is this? What's the rhythm?
sinus.
You sure it's sinus?
Wait,
Is this sinus rhythm, doc?
no.
So why is it not sinus?
There's two P waves.
Now we're talking. There are some P waves here that don't have KRS complexes. Does that make sense? So this is my P,
Yeah.
KRS, T. P here, where's the KRS here? It's missing. Can you see that? Then I have P, KRS, T, P, KRS, T. And I have P, KRS missing, P, KRS missing, P, KRS. Is this a sinus reading? No, not sinus. Are we on the same page?
Yeah.
So far, so good?
Yeah.
Okay. So what do you think is going on here, Doc? Why will some P waves not have KRS complex? Clearly, there's atrial depolarization, right? So why am I not seeing ventricular depolarization for some of them?
Looks like maybe
Hmm?
so maybe it's there's a problem, like there's
Problem
not
what?
ventricle something. So if the like it's kind of like a maybe like
Hmm?
maybe um because there's ventricular depolarization sometimes, and then there's not
Right.
ventricular.
So what do you think would explain that? Think about it. Think about it. Right. Think about it normal, and then tell me why. What would go wrong with that normal? What we expect is a normal sinus rhythm that would explain this.
Um,
First
I think
question: is something wrong with the SA node? Let's start with the sinus rhythm. Is the problem at the level of the SA node? Yes or no?
no,
How do we know it's not the SA node?
because there's P wave.
Is the problem at the level of the atrium?
Um, uh, no,
No. Why? How do we know it's not the atrium?
because there's some QRS complexes.
Because there is P wave and the P waves look normal. Yes or no?
Yeah,
Okay, thank you. Now tell me what is the next structure after the atrium that I should think about?
the vent the ventricle,
Nope, nope.
the
AV node. So it's the problem at the level of the AV node.
mm, the
Yes, problem at the level of the AV node because if I depolarize the atria, where will the conduction go through to get to the ventricle? That's to go through the AV node. So if I'm not seeing KRS complexes, what does that tell me? AV node is completely blocking some of the conduction from getting through. Does that make sense? Does this make sense?
Can you repeat it again? It cracked when you were saying it.
If you leave the ventricle, how would the conduction get to the, sorry, if you leave the atria, how would the conduction get to the ventricle?
Through the AV node,
So if I'm not seeing anything, I'm not seeing ventricular conduction, where's the problem?
the AV node.
What is the AV node doing? What's wrong with it?
Um, is not transferring the signal to the ventricle.
The AV node is blocking the action potential from going through. It's blocking some of the action potential from passing through it to get to the what to the ventricle. Is that clear or not?
Yeah.
Does it make sense? Okay. So what are we dealing with here? We're still dealing with what? Some sort of AV block. Is the AV block we're dealing with here the same as the one we saw before?
No,
So what type are we dealing with here? Much more severe or milder?
severe.
So which makes it what degree?
Second degree.
Second degree AV block. Yes.
Yeah.
And another way you can also report this is what there's about three to so for this set that we have here from beginning from here all the way to maybe these two. This is like 2-to-1 conduction. For this set here, we have almost what we have like 3-to-1 conduction. In other words, you have three waves, then one carries before one carries complex or something like that, right? So this is pretty bad. Three P waves for just one carrier complex, or two P waves, one carrier complex, right? Yeah, so the AV node is blocking some of the action potential from getting to the ventricles. So this is a much more severe block than the previous one, where we just have prolongation but no complete block yet. But here now we're seeing some intermittent complete blocks. So this is a second degree block. Clear? So far so good?
Yeah, the first one was just a long PR interval, right?
Yes.
First, okay. All right.
So read the second ECG for me quickly.
Uh, okay. So we're gonna do rate first. It is bradycardic rate like 50, about 50.
Okay, above 15. Okay. So we're doing some sort of bradyarrhythmia, correct? Okay, go ahead.
Then there's rhythm is irregular.
Okay, rhythm is irregular.
Then the the is 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 not sinus
It's not sinus.
because there's some absent QRS complexes.
Okay, where?
Um, the the this the after the third QRS complex.
Thank you very much. So this is a P, there is no QRS here. And I have under P, very good. So this is not a sinus reading. Now tell me, what will you be thinking when you see that some P waves or a P wave doesn't have QRS complex?
You're thinking some kind of AV block.
AV block. So is the AV block, what degree do you think this would be? Is it the same as the first that we saw or not?
No.
It is also like, so what degree?
Um, looks like it's hmm, there's only I think maybe third degree.
Is also second degree.
Yeah. Okay.
Right, because it's basically almost what does it have in common with the one above? Intermittent block. It's not every P wave that is blocked, correct? Just some. Does that make sense? So it's worse than the first degree where there's no complete block yet. But it is less than the third degree where there's going to be complete block. For every P wave, you won't see any carrier complex following the P wave. Right. But for this one, there are some P waves that have carrier complex, but there are some that don't. So it's intermittent block. It's not as bad as third, but it is worse than first. Does this make sense? Clear?
Yep. Doc.
So what's the difference between the first and they're still different, although they have that in common, intermittent block in common, but they're still different. Tell me which one is worse, the first one or the second one? They're both
The
second degree, but which one is worse?
the first one.
The first one is worse, which makes it what, second degree type 2. And the first one is second degree type 1. Also called Mobit 1 or Winkyback. Second degree type 2, also called Mobit 2. So the top one is worse because we have 3 P waves that are with to 1 Keras complex. For this first one, we have about 4, 1, 2, 3, 4 P waves, 3, right? So it's about like 4:3 ratio for the one below. So it's not as bad. Which means out of the 4 P waves, 3 has half Keras complex, only 1 doesn't. For the top one, we have about 3. Out of the 3 P waves, 2 doesn't have Keras complex, only 1 has, right? So which means the worst block than the one below. Another difference between them is what? Is the PR interval. So look at the PR interval. In the first one, so this is what a PR interval here, which is like normal, one big box, normal, normal. We don't have PR interval for that one, normal, normal. So the PR interval for type 2 is constant. It can be typically normal or prolonged, but it's going to be the same for any P wave that has Keras complex. But you see, for the type 1, there's a progressive, right? So look at the PR interval for the first What happens to the period interval for the second? You can see it's longer than the first. Third one is longer, and then you now have the dropped beat. And this one too, normal, PR interval, prolonged, even longer, then drop it. So there's going to be, for this one, there's progressive prolongation of the PR interval before the drop beat. But for type 2, the PR interval is usually constant, which can be prolonged or normal, but it won't change. It's the same for all of them. But for type 1, there'll be progressive prolongation, which almost, you can see, it's closer to first degree in that category. First degree has prolonged PR interval. This one has prolonged PR interval and then drop it, which is worse than first degree, makes it in second degree type 1. And then in type 2 now, whether I have prolonged PR interval or it doesn't matter. There's just worse block there. So there's going to be more P waves without KRS complex, but the PR interval can be constant. That's type 2. And then the worst of them all will now be what? Will now be your third degree, but there will be a complete block. So how do I diagnose third degree, or how do I figure out third degree? Look at this ECG that we have here. Let's use the lead at the bottom, the long lead. So actually, lead. So we can use any part of it. We can use the first line as well. So if you look at this one, first of all, let's start with rate as well. Rate TS2 is pretty slow, right? Can you see that? So this is slow for sure. What about the reading? Regular, irregular. Actually regular, right? I mean, the distance, all of them look equidistant for the RR intervals. It is regular. Tell me about it, if it's sinus or not.
No, it's not.
It's not sinus because if I look at the one at the top, what do I see? P. I have two P's.
2 to 1.
KRS T. P, P, KRS T. P, P, KRS T. Very good. So not sinus.
2 to 1. Right?
Now, when you see this, right, be careful, right? Because this can be what? Second degree, right? Or it could be third degree. So how do we know? You're gonna know, right, by looking at the rate. So if you notice this place, let's say let's check the P wave. What's the rate of the P wave in this person? For the second degree at blocks. The rate is so 1, 2, 3, 4. And what's the rate for so the rate for the P waves basically the same, and they're also regular and all that. And yeah, we have drops beats basically. This is straightforward. This one too has like the same rate. P, they usually have the same rate, and they have the same rate, almost the same rate as these guys as well. Almost the same rate as the RR interval, their corresponding RR interval. So basically, the distance between these two is going to be the same as the distance between these two. So they all have the same rate, no matter what. But you see, in third degree, right, you're looking for what we call AB dissociation, which means if there's a complete block, right, between the ventricle and the atrium, what will be pacing the atrium? SA node, right? But what will be pacing the ventricle? The ventricle will be paced by a different pacemaker, right, below the AV node. I don't know if that makes sense. Right. So what happens to the ventricular rate? The ventricular rate will be different from the HR rate. So if I check the rate of the atrium in this case, so we have our P's, 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 P's. What's their rate? 1, 2, 3. Let's have about 4 big boxes. So the rate is normal, sinus rate between 60 to 100. But check the rate of the RR. 1, 2, 3, 4, 5, 6, 7. And the rate of the RR is what is slower. So which means that what the ventricles are being paced by something else, by a different pacemaker, which can be a pacemaker from the AB node, from the bundle of below the AB node, bundle of E's, the AB node itself, the lower part from the Purkinje fibers or from the ventricle itself, ventricular muscles. But the atria is still being paced by the SA node, and that's why the atrial rate will be normal. We're going to see that what the ventricular rate will be what? Slower than the atrial rate because it is paced by different, and this is what called AV dissociation. There's a complete disconnection between the atria and the ventricle, and this is what is a third degree heart block, 100% block, right, of the AV.